In this section, we're going to talk about graphing quadratic functions, and we're going to do it using two methods, either the standard or vertex form, and then we're going to look at it again using transformations. Now, before we begin our graphing, we want to kind of remember what a quadratic function looks like and what the characteristics of it are. First of all, our quadratic function is given as ax squared plus bx plus c. This is actually what I would call the general form of a quadratic function. You know it's quadratic simply because the variable x is raised to the highest power of 2. That makes it quadratic. Now, another thing we want to talk about is when you're looking at whichever form of the quadratic function we have, this leading coefficient of a, when a is positive, my function faces up. It points up. And you can see that's what I have here. Something else about this function is at the bottom of the function, right here where it changes direction, we would call this the vertex. Okay, the vertex in this case would be a minimum. This is the minimum value for this function. And my function is symmetric about a line that passes directly through the vertex. So it's a vertical line that passes through the vertex right here. And this is the characteristic of a positive, or when the coefficient a is positive. Now we have also the other form over here where you can see that this picture looks exactly the same except it is pointing down. And that is an indication, although the equation would look similar, the a in this case has to be negative. Okay, so this is when a is less than 0 or negative, and that is an indication that my parabola is going to be, or my quadratic function is going to be facing down. I still have an axis of symmetry. I still have a vertex where the axis of symmetry passes through, except when my quadratic or parabola faces down, I have a maximum point instead of a minimum point. So these are the two types of quadratic functions that we're going to be graphing in this section.